Hi. In this video, we'll be talking about the domain name system, or DNS. So to recap, the internet is all about sending digital information. It's about getting binary data from one computer to another over a network. And the question is, how do two computers find each other? Well, we've seen that every computer on the internet has its own unique address, its own internet address, and that is defined by the Internet Protocol. So this is an example of an Internet Protocol address, or an IP address. For example, I can actually type in Google's IP address into my browser, and it will take me straight to Google. And I paste Google's IP address, which is that. We see it takes me straight to Google. So this is great. Every machine on the internet has its own address, and by typing in that address, we can get to that machine. This is a great system for giving each device a unique address on the internet. The problem is, these IP addresses are not great for us internet users to find. It's great for actually giving a unique address to every location on the internet. But you don't really want to be typing in all these numbers into your browser. You want to be typing in a name, such as google.com or codehs.com. So, how can we solve this problem? How can we give more human-readable and human-usable names to these locations on the internet? Well, the answer to that is DNS. DNS stands for the Domain Name System. DNS translates names to IP addresses. So how this works is a website, for example, Google or CodeHS, will register a domain, such as google.com or codehs.com or wikipedia.org. And once they have this domain, the DNS system will map this domain to a particular IP address, which is its actual physical location. You can think of it like an address book. You have all your friends, and you have all your friends' phone numbers. You don't really want to remember all your friends' phone numbers, you just want to remember your friends' names. So an address book will keep track of which friend has which number. So all you have to do is remember the name, and then you can go and look it up to get the actual number. The DNS works in a similar way. It is an address book mapping domain names, such as google.com, to actual IP addresses. So what does this mean for actually browsing the internet? How do we actually get a resource from the web? Well, turns out these web servers that serve up resources like web pages and videos and images, they aren't actually sitting at addresses such as google.com or codehs.com. They're sitting at actual IP addresses. So if we want to visit these web servers, if we want to get in contact with these machines, we need to actually get those IP addresses. And this is where DNS comes in. So DNS will translate a name into an IP address. So this is the story. If we type the URL www.example.com into our browser, the DNS system will turn this name into an IP address so we can actually visit that website. So the very first step is your computer will check to see if it already knows where it is. Your computer keeps track of websites that you visit a lot so that you don't have to go through this process every time. So it will check in memory and see if it already knows the address for example.com. In this case, it doesn't. And one note, it's not actually called memory, it's called the cache. Your computer will check the cache for this address. If we don't actually know the address for www.example.com, then we start using the DNS system. So to translate this name into an IP address, the DNS system will work backwards on this domain name. So the very first step is to find where com lives. Your computer will ask a root server, where are the com domains? And the reason it starts this way is because DNS is set up as a hierarchy. At the very top is the root. There are several root servers that only store information about top-level domains, such as .com, .edu, .org. And so the root servers only know where to find the top-level domain servers. So your computer will go to a root server and say, hey root, where can I find information about .com domains? And the root server looks over all of the top-level domains, finds the com top-level domain, and says, hey, go check out this IP address. So now we have an IP address for a com name server. Now that we have that, we can go to the com top-level domain server, or TLD server. So now that we're at the com level, we can go one layer deeper to the second level domain. The com top-level domain server only stores information about the com section of the internet. It knows where to find codehs.com, it knows where to find example.com, it knows where to find google.com. All the locations of the .com domains are stored in the com top-level domain server. It doesn't worry about gov, it doesn't worry about edu, it doesn't worry about org. We split this up so that we have less searching to do. So your computer will go to the com server and say, hey com, where can I find information about example.com domains? The com will look over all of the domains it's in charge of, and finally it finds an example.com name server. and it says go check out that IP address. So now we have example.com, and you can go to a hosting server, an example.com server, because you have that IP address now, and say, hey, example.com, where is www? So at this layer, we're at example.com, and the example.com server only stores information about all of the example.com subdomains, such as www, about, mail, info. So these are all subdomains of the example.com domain. So we say, hey, example.com, where is the www.example.com domain? It says, oh yeah, www, that's at this IP address. And now we have the IP address. We're gonna save that in the cache for later so we don't have to go through this whole process again. And now that we have the IP address, we can actually send the request to that server. So we have www.example.com's IP address. We plug that in and we can actually find that server at that address on the internet. We send a request to that server saying, send me your homepage. And then it'll send back its home.html homepage. And the browser will actually turn that into the website that you view. And all of that happened in under a second. It's incredible. So this is a very important point, that DNS is set up as a hierarchy. At the top level are the root servers. The root servers only have information about the top level domains such as com and gov and edu. And each of these top level domains only store information about all the second level domains such as google.com or codehs.com, or the edu will store stanford.edu and berkeley.edu, etc. So your codehs.me website is actually a subdomain of the codehs.me domain. So carol.codehs.me, calvin.codehs.me, those are subdomains of the codehs.me domain. And the reason we do this is because it makes the system scalable. Each layer is only in charge of a small amount of information, so it's very easy to add a single element to a layer. It's easy to add a new layer, and searching one layer is so much faster than searching the entire internet. We don't want to have each layer in charge of every possible domain. We're going to split it up into com and gov and org, etc. So if we wanted to find carol.codehs.me, it's so much faster to march down this tree, march down the hierarchy, than to search every possible domain name. We just have to go to the root, say, hey, where's the me top-level domain server? It takes us down to the me. Then once we're at the me server, we say, where's codehs.me? And that takes us one level down to codehs.me. When we're there, we say, where is carol.codehs.me? And that takes us one level down to carol.codehs.me, and then we actually have an IP address that we can go visit. So that is the DNS system. The big takeaway here is that DNS maps human-readable domain names into actual physical IP addresses.